Hello and welcome to this lesson on writing balanced ionic equations. In today's lesson, we will firstly explain the fundamental concept of ionic equations. Then we'll learn step by step how to write and balance these equations to accurately represent chemical reactions involving ions. In today's lesson, we're diving into ionic equations. This will give us insight into how ions behave in chemical reactions. Let's break down this concept and learn the step-by-step process to write and balance ionic equations. Ionic equations specifically represent reactions involving ions, rather than just neutral atoms or molecules. They allow us to focus on the key players in a reaction, presenting a clearer picture of what happens at the ionic level. An ionic equation typically involves compounds separating into their constituent ions when they dissolve in water or an aqueous solution. For example, when sodium chloride dissolves in water, it dissociates into sodium ions and chloride ions. To write an ionic equation, start by identifying the reactants and products in the chemical reaction. Let's use a simple example, a reaction between sodium chloride and silver nitrate in an aqueous solution. This reaction produces solid silver chloride and sodium nitrate in solution. Next, represent all the ions present in the solution as separate species. For our example, this would involve dissociating the aqueous compounds into their ions. Note that we do not separate any compounds that are in the solid, liquid, or gaseous states, only the aqueous ones. This is the complete ionic equation, showing all the ions involved in the reaction. Spectator ions are ions that do not participate directly in the reaction. They appear unchanged on both sides of the equation. In our example, the sodium ions and nitrate ions are spectator ions. Removing them simplifies the equation to focus on the ions involved in the chemical change. This is the net ionic equation, highlighting the actual chemical reaction taking place. To balance ionic equations, ensure that the number of atoms and the charges are the same on both sides of the equation. For our net ionic equation, the equation is already balanced in terms of both atoms and charges. You can pause the video here to see the breakdown of ions on each side of the equation. However, in more complex reactions, you may need to adjust coefficients. Always confirm that the total charge on both sides of the equation is balanced. The sum of the charges in the reactants must equal the sum of the charges in the products. By following these steps, you can write accurate, balanced ionic equations. Let's practice some examples together to solidify this skill. Let's dive into some GCSE level questions to apply our understanding of writing balanced ionic equations. Write the balanced ionic equation for the reaction between aqueous barium chloride and aqueous sulfuric acid to form solid barium sulfate and aqueous hydrochloric acid. Pause this video to work it out before we go through the answer. First, you need to identify the reactants and products and write a balanced equation. Our reactants are barium chloride and sulfuric acid, while our products are barium sulfate and hydrochloric acid. Therefore, the reaction equation is as follows. To balance this equation, we need to multiply hydrochloric acid by 2, which gives this balanced equation. Write the complete ionic equation by dissociating the aqueous compounds into their ions. We can see that the spectator ions are 2Cl- and 2H+. We can exclude the spectator ions to write the net ionic equation, which you can see here. Check that the equation is balanced in terms of both atoms and charges. We can see that both sides of the equation have one barium atom and one sulfate atom. We can also see that both sides have a total charge of 0. Therefore, the equation is balanced. This means we have reached our net ionic equation. Write the balanced ionic equation for the reaction between magnesium and hydrochloric acid to form magnesium chloride and hydrogen gas. Pause this video here before we go on to work it out. Our reactants are solid magnesium and aqueous hydrochloric acid, and our products are aqueous magnesium chloride and gaseous hydrogen. Therefore, the reaction equation is as follows. To balance this, we need to multiply HCl by 2. Then we need to write the complete ionic equation by dissociating the aqueous compounds into their ions to give the following equation. We can see that our negative chlorine ions are spectator ions, as they don't change from reactant to product. Therefore, we can exclude the spectator ions to find the net ionic equation. Now we can check that the equation is balanced in terms of both atoms and charges. We can see that both sides have one magnesium atom and two hydrogen atoms. We can also see that the total charge on both sides is 0. Therefore, this remains as our net ionic equation as it is balanced. By practicing these examples, you can see how to write and balance ionic equations, focusing on the ions that undergo a chemical change and excluding any spectator ions. In today's lesson, we delved into the world of writing balanced ionic equations. We began by understanding what ionic equations are and why they are important. They represent reactions involving ions, providing a clearer picture of the chemical processes at the ionic level. We then learned the step-by-step process to write these equations. First, we identified the reactants and products in a chemical reaction. Next, we wrote the complete ionic equation by dissociating the aqueous compounds into their constituent ions. Following this, we identified and excluded the spectator ions, which do not participate directly in the reaction, to simplify the equation to its net ionic form. Finally, we discussed the importance of balancing ionic equations. By following these steps, we can write accurate, balanced ionic equations, enhancing our understanding of ionic interactions in chemical reactions. This lesson has equipped us with the necessary skills to represent chemical reactions at the ionic level. Practicing these steps will help solidify this important skill in chemistry.